Okay, for what we have in this particular second part of Aleks-Section R.5, we have an absolute value equation whereupon we have the absolute value of 4w minus 4 followed by the addition of 12 is equal to 48. And looking at what we have here, okay, so the object is going to be, for right now, to isolate the absolute value of 4w minus 4. So I can go ahead and take away 12 from both sides. And in doing so, I have the absolute value of 4w minus 4 is equal to 36. Now, once I take out the absolute value signs or symbols that surround 4w minus 4, okay, I'm going to have 4w minus 4 equal to the values that will have an absolute value of 36. So the two numbers that are 36 units away from 0 on the number line will be positive and negative 36. So we have two numbers with an absolute value of 36. And for what we have in the case of w, I'm going to set up two equations. One whereupon 4w minus 4 is equal to negative 36. The other where we have 4w minus 4 is equal to 36. And we have in both cases adding 4 to both sides of both equations. We have 4w in the first equation equal to negative 36 plus 4, which is negative 32. And we have with division by 4, okay, we have negative 32 divided by 4, and we have w is equal to negative 8. For the second equation, adding 4 to 36, we have that 4w, okay, it's going to be equal to 40. And we have with division by 4, okay, we have that w is equal to 10. Okay, so we have two values for w, and they will be at negative 8 and positive 10. And so taking back to what we have here, so we have negative 8 and 10 and checking, and the result is correct. Okay, now in the case of the crossover to solving for the variable, we now have a radical equation, and we have w2 up here once again, and we have this in the form of 1 is equal to the square root of 3w minus 9 followed by the subtraction of 2, and looking at solving for the radical equation. Okay, so we have a radical expression in the form of the square root of 3w minus 9, and if I isolate the radical, so I will add 2 to both sides, and here we have 1 plus 2 is going to be at 3, and we have that 3 is equal to the square root of 3w minus 9. And again, we have only one radical term, and that is in the form of a square root. So I can free up the binomial upon squaring both sides of the equation. And squaring out, you have 3 squared is 9. And we have that 9 is equal to 3w minus 9. And upon adding 9 to both ends, so we have that 18 is equal to 3w, and dividing both sides of the equation by 3. Okay, we're going to have that w is equal to 6, and checking what we have here. And the result is correct. Now, in looking at solving for u, okay, we have another radical equation, and we have here that u is equal to the square root of 10u minus 21, and we have the variable to appear twice, And okay, so we have one radical term, and that is in the form of the square root of 10u minus 21. And looking at squaring both sides of the equation, so we have u squared is equal to 10u minus 21. And here we have a quadratic equation. And putting this in standard form, that is setting the quadratic equal to 0. And we're going to have, in the case of the rewrite, so you have u squared minus 10u plus 21 is equal to 0. Here we have a factorable trinomial. And the factors of 21, that will add up to negative 10. We have negative 3 and negative 7. And utilizing the zero product property, and we have upon setting u minus 3 and u minus 7 to 0, okay, so we have u equal to 3 and u equal to 7. Now, if we check the results, so checking u equal to 3. Now, you do not have to write this out. If you can see it visually, if you're going to have consistency, that's fine. But I just want to mention, okay, so we have, again, there's the possibility of extraneous roots that will not qualify solutions in the case of even root radical equations. So if u is at 3, we have 3 is equal to the square root of 10 times 3 minus 21. 10 times 3 is 30, minus 21 is 9. And we have the square root of 9 is equal to 3, so we have consistency. And checking out what we have for 7. So going back to what we have with the original equation. So again, we have u is at 7. Square root of 10u minus 21. We have the square root of 10 times 7 minus 21. 10 times 7 is 70 minus 21, so this would be at 49. And the square root of 49 is 7. So we have two solutions for u, and those will be at 3 and 7. And checking what we have in Alex. So we have with u at 3 and 7, checking, and the result is correct. Okay, for the next item, we have a special case in the radicals, whereupon we have 1 plus the square root of u is equal to the square root of u plus 15. And now we have the appearance of two radical terms with the square root of u and the square root of u plus 15. And what we can do here is that we can go ahead and square both sides, and we're going to have in this case, all right, so if I square both sides, now for the easier part, we have the square of the square root of u plus 15. So this will come out to u plus 15. Now for what we have in the case of 1 plus the square root of u, quantity squared, this would translate out to 1 plus the square root of u times itself. And if I FOIL out, okay, so you have first product is at 1. Outside product, we have the square root of u. Inside product is also the square root of u. Now we'll mention, okay, for the last product, we have the square root of u to the second. And we have combining, we have 1 square root of u. Square root of u is going to be 2 times the square root of u. And the square root of u squared, okay, that is going to be at u. And just looking again at what we have here. Okay, so I have 1 plus 2 times the square root of u plus u is equal to u plus 15. Now I'm going to isolate the radical. So in taking what we have here, if I isolate the radical, so I'm going to take away u from both sides, and I can take away 1 also from both sides, and we are down to 2 times the square root of u is equal to 14, and I can divide by 2. We could actually go ahead and square both sides, but we'll just go ahead and divide by 2. So we come down to the square root of u is equal to 7, and we have upon squaring both sides, the square root of u squared becomes u. 7 squared we have at 49, and this is our only apparent solution. And if we check what we have with 49, okay, so we have 1 plus the square root of 49, and we have is equal to the square root of 49 plus 15. Now we have 1 plus the square root of 49 is going to be 1 plus 7. The sum of 49 and 15 will be at 64. And we have that 1 plus 7 is going to be at 8. And the square root of 64 is also going to be at 8. So we do have consistency. And just checking what we have for u at 49. And it is correct. Okay, now for what we have, looking at solving the equation in terms of a variable. And if you notice, we have this equation is expressed in terms of c equals. And we have c is equal to the square root of 9d. Now if I were to reconfigure the terms where the equation is written in terms of the variable d, so I need to free up d from the square root of 9d. And okay, so I want to free up the d. Okay, and right now we have the square root, so I can square both sides. And squaring both sides, so I have c squared is equal to 9 times d. And isolating the variable d, okay, so we have a division by 9. Okay, so we have c squared over 9 is equal to d, which is equal to the statement d is equal to c squared over 9. And checking, so you have c squared and dividing by 9, and the result is correct. Now we have in this particular portion a fairly quick answer item, and it says to solve for x, where x is a real number. Okay, and here we have the cubic root of x is equal to 5, and here we want to free up x from the cubic root, so I can eliminate cubic roots by taking both sides and raising to the third power. So we have the cube of the cubic root of x. This will go to x. And 5 to the third is 125. And that is our solution for x. And checking the result, and it is correct.